So it is given to represent -9 in sign magnitude, 1s complement and 2s complement format, and we have to use a 8-bit format for this. So first we have to represent -9. So first we have to see how to represent +9. The first step while representing any decimal number in binary format is to split it in parts with powers of 2. So we can split 9 as 8 plus 1, okay, where 8 is 2 to the power 3 and 1 is 2 to the power 0. Okay, next, if you are a complete beginner, proceed in this way. Okay, so 2 to the power 7, 2 to the power 6, 2 to the power 5, 2 to the power 4, 2 to the power 3, 2 to the power 2, 2 to the power 1 and 2 to the power 0. Why? Because we are using 8-bit formats. Okay, so this is the weight associated with each bit. Now there will be one where we have these values, 8 which is 2 to the power 3, so in this position we will have 1, and also in the position 2 to the power 0 we will have 1. All remaining bits will be 0, 0, 0, 0, 0, 0, 0. So this is the binary representation of +9. Now the sign magnitude format. So in sign magnitude format, the MSB bit, this, okay, this bit is called as the sign bit. Okay, the MSB. If it is 0, it represents a positive number. If it is 1, it represents a negative number. The remaining bits, they are called as the magnitude bits. So one bit is used up in just telling whether the number is positive or negative. So the number of bits that can be used to represent the numbers, it is decreased, as one bit is used up in telling the sign, whether it is positive or negative, whether the number is positive or negative. So now you can guess what will be -9. So +9 is 0, 0, 0, 0, 1, 0, 0, 1. So -9 will be, in sign magnitude, this 0 will become 1, and remaining magnitude bits, it will remain same as they are. That is 0, 0, 0, 1, 0, 0, 1. Okay, this is for -9, and this is sign magnitude method. Okay, this is the first method which we have. Next is the 1s complement method. One S complement method. So in this method, +9, it is represented in the same way as we do in sign magnitude format. Okay, in the same way, that is 0, 4 zeros, then 1, 0, 0, 1. Okay, plus 9 is represented in the same way as sign magnitude method, same as sign magnitude method. But minus 9 is represented as the 1s complement of this binary representation of plus 9. What is 1s complement? It means we have to change 0 to 1 and 1 to 0. Invert all the zeros to 1s and 1 bits to 0. Okay? Just replace 0 with 1 and 1 with 0. So here it will be 1, 1, 1, 1, 1 becomes 0, so it's 1, 1, and this is again 0. Okay, this is called as the 1s complement. Okay, this is the 1s complement method. Okay, this is minus 9 in 1s complement. Next method is the 2s complement. So in 2s complement method also, plus 9, that is the positive integers, they are represented in the same way as sign magnitude method, that is 0, 0, 0, 0, 1, 0, 0, 1. Okay, same as sign magnitude method. Minus 9 is represented as 2s complement. So 2s complement is one is complement representation with 1 added to the LSB of the 1s complement representation. That is, first you will take the 1s complement representation here, which is this one, 1, 1, 1, 1, 0, 1, 1, 0, and will add a 1 to the LSB of the 1s complement representation. So we'll have 1, 1, 1, 1, 0, 1, 1, 1, 1. This is called as the 2s complement. Minus 9 represented in 2s complement. This. Now there is also another method of a shortcut method to determine the 2s complement. So see, first we'll have here plus 9, okay? Plus 9 is 0, 0, 0, 0, 1, 0, 0, 1. So here what we'll do is you start from the LSB side until you arrive at the first 1 bit. So here the LSB bit itself is 1. So you will keep all the bits up to you arrive at the first 1 bit same as they are. So here the LSB bit itself is 1, so only that will remain constant, that is as 1. Okay, let me use this ink. Okay, it will remain as 1, and the remaining bits, okay, the remaining bits we will invert them. That is, we'll take the 1s complement of them. That is, 0 will become 1, again 0 will become 1, 1 will become 0, and the remaining 4 zeros, it will become 4 ones. Okay, same as this one. Okay, same as this. So this is a shortcut method to determine 2s complement from the positive integer representation. Start with the LSB side until you arrive at the first 1 bit. Keep all those bits up to that first 1 bit that you arrive same, constant, and after that you invert the remaining bits. Okay, for example, let's say, let me use another example to make my point. So let's say we have the positive representation something like this. We have any, I'm not picking any number, I'm just trying to make you understand what I'm saying. So let's say we have something like 1 2 3 4. Okay, this is the positive number representation, and we have to take the 2s complement directly. So what we'll do, we'll start from the LSB side and we will move forward until we arrive at the first 1 bit. So here this is, up to this we will keep as it is, we'll copy it as it is, and the remaining bits we will invert them. That is, here 0 will become 1, 1, 1, 1. This will be the 2s complement. Starting from the LSB side, we kept the bits as the same until we arrived at the first 1 bit. We copied it as it is, it was same up to this position. After this, these remaining bits, we inverted them. We took the 1s complement of the remaining bits. If there would have been a 1 present here, it would have become 0. Okay, just like that. So this is the 2s complement representation of -9 here, this. Okay, this one. So a very simple example here, and we understood how to represent a negative integer in sign magnitude, 1s complement and 2s complement form.